this one by substitution, keep in mind one thing. I will never substitute for y because it has 3 in front. I will never substitute for this y because it has 2 in front. And I will not substitute for this x because it has 2 in front. You can say, yes, but you can simplify this both sides by 2. Yes. But since I do have one of the variables that has a leading coefficient, or a coefficient, I should say, of 1, I will solve this for x. And yes, I can still simplify the second equation both sides by 2. So if you solve this equation for x, what will you write? You have to move it from one side to the other. It cannot have the same sign, right? Yes. So minus 3y minus 5. Yes, here you can divide by 2, and I recommend it. So the second equation becomes x plus y equals 3 when we divide both sides by 2. X plus y equals 3. I copy the first equation right here because I'm going from one page to another. It's easier for me to keep them together, and you should always do that actually. And now I can apply the substitution method. What will you substitute and where? You will replace x from the first equation by this quantity. Exactly what we did a minute ago with y. So I take x from the second, that's why I solved this equation for x to replace x in the second equation. So now can anyone give us that first equation that right now is the first equation in my system? Can anyone dictate? Don't calculate anything, just dictate what you would write as the first step. Plus y equals exactly. So using substitution, we basically combined 2 equations into one. We took a variable from one equation and we replaced it in the other one. And now this I can solve. It's a linear equation with one variable, one unknown. I will combine like terms, so I have negative 2y, and of course I will have to move 5 to the other side and it becomes positive. So how much is y? Good. Now this is not enough. I need to go back to the equation, to the substitution, and change y, replace y by negative 4. So how much is negative 3 times negative 4? Negative 3 times 12. Yes. 12 minus 5. Very good. It appears that the solution, we don't know yet. By the way, is the system consistent? It has a solution. Is it consistent? Yes. So it's the first case. Okay, very good. So it appears that the solution is 7, negative 4. Do you trust that? I don't. I have to go back and check. So I'm going back to the original problem with 7 and negative 4, with 7 and negative 4. Well, let's see what happens. 3 times negative 4 is negative 12. 7 minus 12 is indeed negative 5. Check. 14 minus 8. 14 minus 8 is indeed 6. Check. And I don't need anyone to tell me whether it's correct. I checked in both equations and it works. Any questions here? Any questions? Any questions? Is this okay? Okay. The third method that I would like to talk about is the adding method called adding or elimination. So this is 4.3. Okay, let's establish something before we continue. I have 2 markers in my hand. Assume, okay, they are completely identical. They have the same weight. They have even the same color, everything. So they are equal. They're equal. Okay? This equals this. Imagine that I have an equation. This equals this. Okay? Now, let's say I add I don't have two identical though, so I'm gonna just convince you that they are. Okay, so these two are equal. If I, and assuming these are perfectly the same, I'm adding here and I'm adding here. Did I destroy the balance? If I put these on a scale, I put them on a scale, are they still equal? Right. So this is the concept that we're going to use now. So I may add a quantity to this side of the equation and a quantity to this side of the equation. They must be the same, but they may not look the same. Okay? So that's the concept behind the adding method. So let me choose a problem. On page 270, let's say a simple, the simplest, yes, 11. 11 on page 270. So I have x plus y equals 6, and x minus y equals 6. Okay. Before we discuss any of this, let's look at the first equation. Just look at the first equation for a moment. We are told that x plus y equals 6. So if I tell you 6, or I tell you x plus y, I'm telling you the same thing. Okay? So what I'm going to do next is I'm going to add this quantity to this side of the second equation, and I'm going to add this quantity to the other side of the equation. Why? Because they're equal. And here's what happens when I do that. Why did this happen? It's because y and negative y had opposite coefficients. Is it done? No. Now I have to find x. How much is x? Good. And I have to go back to any of these two equations to determine y. How much is y? 6 plus what is 6? Perfect. So it appears that the solution is? 6. Do you trust it? No, not yet. You shouldn't. Okay. So I go back to the original system, 6060. Is 6 plus 0 6? Is 6 minus 0 6? So this must be correct. 6 minus 0 is 6. So both equations are true when I replace x by 6 and y by 0. Therefore, this is the only solution. And again, the system is consistent and it has a unique solution. The equations are independent. This was the first level, really, the simplest possible system, solving it by adding. Now, here's the second level. I'm looking at problem 10 on the same page, which is 270. So I have x plus 4y equals 14, and I have 5x plus 3y equals 2. And yes, you could say, well, like you did before, add this quantity here and this quantity here because they're equal. True, but nothing will go away. So just doing that is not going to help. There is an intermediate step. I have to decide which variable to eliminate. Here I didn't have to decide because this one had positive y and this one has negative y. But here I have to make a decision. Do I want to eliminate x or do I want to eliminate y? Which of these two is easier to eliminate? X. But it means that I have to multiply both sides of the first equation. I didn't mean to put that comma. I have to multiply both sides of the first equation by exactly negative 5. Only negative 5 will work. Exactly. Because I need to get the opposite of 5x. And the opposite of 5x cannot be determined in any other way but if I multiply the top equation, both sides, by negative 5. So let's always keep the equations together. So negative 5x, negative 20y equals negative, is it 70? And then 5x plus 3y equals 2. Now it makes sense to add. I had a plan and I reached my target. My target was to eliminate x. Multiplying both sides of an equation by -5 does not change the solution. And I did it on purpose because I wanted to eliminate x. So therefore I have -17y equals -68. I will divide both sides by, and what do I get? Very good. Excellent. Am I done? No. Do I know that the system is consistent? Yes. If I found y, I would find x. Good. So let's go back. Doesn't matter where you want to go back. I would prefer going back here and say x plus 16 equals 14, which will give us y to be -2. So then it appears, we don't know yet, it appears that the solution is 4. I have no clue. I can make mistakes, everyone can, so I go back. -2, 4, -2, 4. Let's do it. 4 times 4 is 16. 16 minus 2 is 14. Check. This is -10, and this is 12. -10 plus 12 is indeed 2. And then I'll say, yes, I checked. No doubt. That is the solution, and no one can find another. Now I would like to look at a couple with infinitely many solutions and no solutions, because we want to see that too. Okay, let's look at 13. All these systems so far had one solution, so let's look at other options. So 2x plus 3y equals 0, they say, and 4x plus 6y equals 3. Okay, let's decide. There is nothing I can simplify. I will definitely not use substitution in a system like that, because if I substitute for x, I will have a fraction with 2 in the denominator. If I substitute for y, a fraction with 3, and so on and so forth. So I'm thinking of elimination, or the adding method, eliminating one of the variables. Which one would you like to eliminate? Okay, so it means that you are multiplying both sides of the first equation by? Excellent. So -4x, -6y equals 0, and I copy 4x plus 6y equals 3. Now it makes sense to add. In this first step, it did not make any sense to add. No variable will go away. So what do I get on the left-hand side? 0. And the other side? 3. This makes no sense. Okay, very good. And what do I conclude about the system? Exactly. They are parallel. They must have the same slope. I want to check. I want to convince myself that they have the same slope. So I have 2x plus 3y equals 0. How do I determine the slope of a line? We just did it about 15 minutes ago. We solved for, I need it in y equals mx plus b, so I have to solve for y. So this is 3y equals -2x, and y equals -2/3 x. What is the slope of the first line? -2/3. Don't say -2/3 x. I'm not saying you did. I'm just saying x has nothing to do with the slope. I'm going to do the same thing for the second one. I'm going to solve for y. 6y equals -4x plus 3, because I have to move x to the other side. I divide by 6. So y equals -2/3 x plus 1/2. What is the slope of the second line? And now I know I'm correct. The lines have the same slope, they must be parallel. If two lines, and if the lines are parallel, and how many points will they ever meet? Of course, they do not. Okay. I'd like to solve some word problems now with systems, but let me see. Let's Let's look at one more, like 35. 35, x over 3 minus y equals 2, and negative x over 2 plus 3y over 2 equals negative 3. And you could say, but this is a tough one because it has fractions. Not at all. We will eliminate them as way we please. We'll do whatever we want as long as it's legitimate to that system. And if we don't like fractions, we can make them disappear very easily. No effort at all, really. How will you make fractions disappear in the first one? Multiply both sides by. Very good. How will you make the fractions disappear in the second one? Multiply everything by 2. Good. Very good. So then we have x minus 3y equals 6. Fractions went away. Negative x plus 3y equals negative 6. Fractions went away. Perfect. What now? I'm done. So what is the answer? Equals? Good. Which means we did not determine x, we did not determine y, we did not get a contradiction, we don't have a point, we did not get a contradiction, so what is the only option here? They are the same line, because if you multiply this by negative 1, you get this. So they are the same line. The solution is normally written in the following way. You can write infinitely many solutions, and I'm fine with it, but normally the solution, we solve one of the equations for a variable, like x, and I move 3y. So x equals 3y plus 6. So now, the ordered pair is x, which is 3y plus 6, comma y. This is the elegant way of writing the solution. In other words, if y is 0, this is 6 comma 0. If y is 1, this is 9 comma 1. If y is 2, this is 12 comma 2. If y is negative 5, blah, blah, blah. And you can come up with all ordered pairs like that. I'm fine if you write this, but this is the elegant way of writing infinitely many solutions. Why did we study all this? Why did we study really all these systems and methods and for what follows right now? Okay. So let's look at on page 293, the word problems, and this is the end of chapter 4. So for the five applications. What do you think these applications will turn into? Since they are in chapter 4, what will they turn into? What is the entire chapter 4 all about? So all these word problems will turn into a system of linear equations. Of course. That's why they're here. All of them. Okay. Problem 26 on 293. Joan rented the same car model twice from Hertz, which rents this car model for a daily fee, an additional charge, and plus, I'm sorry, I skipped a word, a daily fee plus an additional charge per mile, and the charge per mile. Okay. Joan recalls that the car rented for 5 days and driven for 300 miles cost her $178. While the same model car rented for 4 days and driven for 500 miles cost her $197. Find the daily fee and find the mileage charge. We rent a car for 5 days, we drive over 300 miles, and we pay at the end of the 5 days $178. Some other time, we rent it for 4 days, We drive it for 500 miles, and at the end of those 4 days, we pay 197. We're asked to find the daily fee and the charge per mile. How many variables does this problem have? Two variables. And what is the first variable? The daily fee. So I'm going to denote this by X. What is the second variable? Very good. I'm going to write it, denote it by Y. How many equations do we have to write if the problem has two variables? Exactly 2. I'm ready when you are.
X plus 300y equals 170.
Excellent. Perfect. So 5 days times the charge per day plus 300 miles times the charge per mile equals dollars. Dollars plus dollars equals dollars. Okay, and we need one more. Okay, let's solve the system. Choose a variable to eliminate. Don't even think of substitution. Choose a variable to eliminate, the easiest of the two, and give me the solution. What will you multiply the first equation by? Okay, perfect. So you have 20x plus 1200y equals, how much is this? 2 and 3, 28, 1, is it 7? 712? Okay, perfect. And then the other one is negative 20x minus 2500y equals negative. Is this 985? Am I correct? Okay. Good. So then I have negative 1300y equals negative 3 and 7 and 2. I hope I'm correct. So then y equals 273 divided by 1300. I got 0.21 dollars per mile. Is this good enough? It's good, but it's not good enough because I have not determined x yet. So I have to go back here and write 5x equals negative 300 times 0.21 plus 178. Plus 178, what did I get? I got 115. So 5x equals 115, and x equals, what is it, 23? Okay, so $23 per day. It appears that the solution is, I'm not sure yet, but it appears to be, comma, 0.21. Let's go back to the original system, back here, and plug them in and tell me whether we get the right-hand side. And I would like to select another problem. Does it work? Both? Perfect. Okay, I trust you. Good. Let's look now at a mixture problem. Okay, like problem 46. A 10% acid solution is to be mixed with a 50% acid solution to get 120 ounces of a 20% acid solution. How many ounces of the 10% and how many ounces of the 50% solution should be mixed? These mixture problems, at first sight, they appear to be difficult. So here's the scenario. Imagine that I have right here a container in which I have an unknown number of ounces of a solution, and I know it's 10% concentration. In the second container, I know I have an acid solution. I don't know how many ounces, but in the second container, I know I have a concentration of 50%, but I have no idea how many ounces in there. And here is the third container. It's empty, clean. I take these two containers and I empty them out completely in the third container. And I know now that I have in the third container that initially was empty, I have 120 ounces and the concentration is 20%. So the question is, how many ounces of the 10% and how many ounces of the 50% we have in the situation? How many variables are there in the problem? Say it again. Okay, one more time. We don't know systems with 3 variables. So we can never do that because we haven't studied it. But let's say one more time. In the first, it's better to go back. The first container, I don't know the quantity, but I know 10% concentration. In the second container, I don't know the quantity, but I know 50% concentration. I have a third container, completely clean, empty. I take these two containers and completely empty them out in the third one. Here I have 20% concentration and exactly 120 ounces of fluid. 2 variables. Okay, so X is the number of ounces in the first container plus Y is the number of ounces in the second container, and I'm emptying everything out in the third container. Okay. Let me remind you something extremely important. All equations must be consistent. Dollars plus dollars equals dollars. People plus people equals people. I cannot say people plus money equals something. Okay, good. So since the equation, since the problem has 2 variables, how many equations do I have to write? 2. Okay. I'm ready when you are. I cannot use percent. You're on the right track, but I cannot use percent in an equation. So I have to write point. Yes, 0.10x plus 0.5 Yes, so stop for 1 second. You said number of ounces times concentration. Good. Which gives you the number of pure ounces of acid in the first solution. Excellent. Plus the number of pure ounces of acid in the second solution. Keep this in mind. Concentration times quantity plus concentration times quantity. Now I'm ready for the answer. Right, because you already said this, but I need to write it for everyone to see. Concentration times ounces. Concentration times ounces plus concentration times ounces equals concentration times ounces. If you stop here, you are saying pure ounces of pure acid plus ounces of pure acid equals 0.2. You're not saying ounces of pure acid. Now you are. You cannot say 120 because 120 is not pure acid, and you cannot say 0.2. Perfect. Perfect equation. Thank you. Okay, now the second one. I have the first container, and I have the second container, and I have the third one that is empty. I empty these out in the third container, and now I know I have 120 ounces.
X plus Y equals 120.
Of course. Okay, let's solve the system. Choose the method you like. You can use substitution if you want. In this one, I don't recommend it in general, but it works. You can come in. Becky, you want to take your quiz already? Here's what I would have done with this problem. Of course, you're right, this is indeed 24, right? But I prefer eliminating these numbers. So I would have multiplied both sides by 10. You don't have to. So I said x plus 5y equals 240, and x plus y equals 120. I would have multiplied the second one by -1. X plus 5y equals 240, negative x negative y equals -120. I would have eliminated this, 4y equals 120, so y equals 30 ounces of solution 50%. And since the total is 120, then x must be 90 ounces of 10%. So the solution appears to be 90, 30. Does it work?
Question.
Yes.
If I multiply the top one by 1 and the bottom by negative minus.
There's no point in multiplying by 1. Multiplication by 1. I'm not saying it's wrong. That's not, multiplication by 1 will not change anything. So you multiply the bottom one by
0.1.
by negative 0.1.
Negative 0.1.
Yes, that's fine. And you got the same answer. Sure, yeah, of course.
You can just multiply the top one by negative 10 and you skip that second step altogether.
True too. Very good. Excellent. Okay. I know I only have 3 minutes left. There is nothing I can do, no problem that I can do in 3 minutes, actually. So here's the plan. Here's the plan for next time, next Thursday. So we do have, so we're done till here. Okay, but I still want to show you more problems from 4.5 and these 3. Okay, so I need about an hour next time, next Thursday, to finish that, and then I will review for the test. And the test will be the following. I need my phone just to look at the calendar. I have a phone? Yes, I have. So let's discuss this.